Enemy at 2 o'clock. Range 800.
Target locked! Fire with aim!
Touch copy. Frontline reports show turret ring stress. Yes, we need a reinforced weld here. Agreed. Mark the changes.
Mount up! Let's move! Yes, sir. Climbing in. Check your maps. Stay sharp.
All units, advance to objective. Stay in formation.
All right, Captain. Push through rapid attack!
June 1940. The morning air over Washington, D.C. is heavy with quiet anxiety. Across the Atlantic, Europe is collapsing. In just 6 weeks, the German army has smashed through Belgium, the Netherlands, and France. Entire armies are falling apart under a new kind of warfare. Fast, mechanized, relentless. German panzer divisions move like steel storms across the countryside, supported by aircraft and motorized infantry. Military observers around the world are stunned. For the first time in modern history, tanks are not just supporting infantry. They are leading the war. In the United States, the news reaches the War Department with unsettling clarity. America is not ready. The U.S. Army, one of the largest institutions in the country, possesses fewer than 400 tanks. Many are outdated. Some are little more than training machines. Most were never designed for the kind of lightning war now sweeping across Europe. The realization spreads quietly through military offices and industrial boardrooms alike. If the United States is drawn into this war, it will need something it does not yet have: an army of steel. But in the factories of Detroit, engineers and workers are about to begin building one. September 1st, 1939. Before dawn, German forces cross the Polish border. Columns of tanks roll forward across fields and narrow roads. Above them, aircraft of the Luftwaffe roar overhead, striking railways, bridges, and command centers. Behind the tanks come fast-moving infantry carried in trucks and armored vehicles. This is not the slow, grinding warfare that Europe remembers from the First World War. This is speed. This is coordination. And this is something entirely new. German commanders call the method blitzkrieg, lightning war. Instead of advancing cautiously along a broad front, armored spearheads punch deep into enemy territory. Tanks bypass strong points and surround entire formations. Air power destroys communications and prevents organized defense. Within days, entire armies become isolated and collapse. Poland fights desperately, but the outcome is swift. By early October 1939, the country has been overrun. Across Europe and the Atlantic, military observers study the reports with growing concern. The tank has changed. Once considered a slow support weapon for infantry, it has become the centerpiece of modern warfare. But the true shock arrives the following spring. On May 10th, 1940, Germany launches a massive offensive into Western Europe. Armies move through the Netherlands, Belgium, and Luxembourg. Allied commanders expect the main attack to resemble the battle plans of the First World War. They are wrong. German armored divisions, commanded by officers such as Heinz Guderian, push through the dense forests of the Ardennes, terrain long considered unsuitable for large armored forces. The maneuver catches the Allies completely off guard. Within days, German panzer units reach the Meuse River. Bridges are seized. Defenses collapse. The armored columns drive west toward the English Channel, cutting off large portions of the French and British armies. It is a campaign of speed and shock. Entire Allied formations are surrounded before they fully understand what has happened. By late May, hundreds of thousands of British and French troops are trapped near the coast. An emergency evacuation begins at the French port of Dunkirk, where Allied ships rescue more than 300,000 soldiers. But the strategic situation is already beyond repair. German armor continues advancing south. On June 14, 1940, German troops enter Paris. 10 days later, France signs an armistice. In just 6 weeks, one of the strongest armies in Europe has been defeated. The world is stunned. Military planners everywhere begin re-examining their assumptions about modern warfare. Tanks, once viewed as supporting tools, are now clearly instruments of decisive power. And nowhere are those lessons more unsettling than in the United States. At the time of France's collapse, the American army is small by global standards. Its total strength is barely larger than the forces of some European nations already engaged in war. Even more troubling is the state of its armored forces. The United States possesses fewer than 400 tanks. Many belong to experimental programs. Others are outdated designs from the interwar years. The Army has no large armored formations comparable to Germany's panzer divisions. Most American tanks are light vehicles intended for reconnaissance or infantry support. They lack the armor, firepower, and operational doctrine that have made German armored forces so effective. The United States has not ignored tanks entirely. During the 1920s and 1930s, a handful of officers argued that mechanized warfare would dominate future conflicts. But their ideas remained controversial. The Army still organizes its units primarily around infantry formations, artillery, and traditional cavalry. Mechanization exists, but only in limited form. Even within military planning circles, there is uncertainty about how tanks should be used in large-scale warfare. The fall of France changes that debate almost overnight. Reports arriving from Europe paint a clear picture. Armies that cannot move quickly, coordinate armor and air power, and exploit breakthroughs with mechanized forces risk catastrophic defeat. American military leaders begin asking a difficult question. If war reaches the United States, or if America is forced to intervene overseas, how will it fight against armies built around armored divisions? The answer at that moment is deeply uncomfortable. It cannot. Not yet. Because the United States does not simply lack modern tanks. It lacks the industrial system, doctrine, and production scale necessary to build them in the numbers modern war now demands. Yet within this challenge lies a possibility. America's greatest strength is not its existing military. It is its industry. Factories across the country produce automobiles, tractors, locomotives, and heavy machinery in enormous numbers. Assembly lines move with a speed and efficiency unmatched anywhere in the world. If that industrial power can be redirected toward war production, the balance could change. But doing so will require more than new weapons. It will require an entirely new way of organizing the American military and the industries that support it. A transformation that begins quietly in the summer of 1940. Summer 1940. Across the United States, the news from Europe continues to echo through military headquarters, industrial offices, and government buildings. The fall of France has done more than change the balance of power on the continent. It has exposed the frightening speed of modern mechanized warfare. American planners understand that if the United States is ever drawn into the conflict, its forces will have to fight armies built around tanks, aircraft, and rapid movement. The traditional structure of the U.S. Army, organized primarily around infantry divisions, no longer seems sufficient. The debate over mechanized warfare, which had lingered quietly for years, suddenly becomes urgent. One of the most influential voices in that discussion belongs to Adna R. Chafee Jr. Chafee has long argued that tanks should not merely support infantry, but operate as independent, mobile formations capable of decisive breakthroughs. The events unfolding in Europe appear to confirm his view. On July 10, 1940, the U.S. Army takes a decisive step. It creates a new organization known as the United States Army Armored Force. For the first time in American military history, tanks will form the core of dedicated armored divisions. Two major formations are established almost immediately: the 1st Armored Division and the 2nd Armored Division. Their mission is clear: develop the tactics, training, and structure necessary for mechanized warfare. Young officers eager to experiment with new ideas begin to gather within these units. Among them is the energetic and outspoken cavalry officer George S. Patton. Patton believes deeply in the power of speed and aggressive maneuver. Tanks, in his view, should move fast, strike hard, and keep advancing until the enemy collapses. But there is a problem. These new armor divisions exist largely on paper. They require thousands of tanks, armored vehicles, engines, transmissions, weapons, and spare parts. The United States Army simply does not possess the equipment needed to build such a force. Designing and producing modern tanks will require something beyond traditional military procurement. It will require American industry. In Detroit, the heart of the American automobile industry, factories already produce millions of vehicles each year. Companies like Chrysler, Ford Motor Company, and General Motors operate enormous assembly lines capable of turning raw materials into finished machines at remarkable speed. These companies know how to design engines, fabricate steel components, and organize large-scale manufacturing. What they have never done is build tanks. Yet by late 1940, government officials begin working closely with industrial leaders to make exactly that happen. One of the most ambitious projects emerges outside Detroit. In September 1940, construction begins on a massive new facility known as the Detroit Arsenal Tank Plant. The plant is designed specifically for tank production. Unlike traditional military workshops, this factory will operate on principles borrowed from the automobile industry. Tanks will move along assembly lines. Specialized teams will handle engines, armor plating, and turret construction. Components will arrive from dozens of supporting factories across the country. The goal is simple but revolutionary. Instead of building tanks one at a time, the United States will manufacture them in mass quantities. The project is assigned to Chrysler, whose engineers begin adapting automobile production techniques to armored vehicles. They redesign machinery, develop new welding processes for thick armor plates, and coordinate a vast network of suppliers providing everything from steel to rubber components. Meanwhile, the Army continues refining its early tank designs. Initial models, such as the M2 medium tank, serve primarily as transitional vehicles, useful for training but not yet fully suited for modern armored combat. Engineers and military planners work together to improve armor protection, firepower, and mechanical reliability. The process is experimental. Each prototype teaches new lessons. Every design change moves the United States a little closer to producing a tank capable of facing enemy armor on equal terms. By 1941, the transformation is already underway. Factories that once built civilian automobiles are beginning to shift toward military production. Workers learn unfamiliar tasks, riveting armor plates, installing heavy guns, assembling turret mechanisms. Many of them have never seen a tank before, but day by day, the machines begin to emerge from the assembly lines. Steel hulls, heavy turrets, tracks designed to carry armored vehicles across mud, sand, and shattered roads. The United States still lacks a fully equipped armored army, but something powerful is beginning to form inside its factories. A vast industrial engine capable of producing the weapons of modern mechanized war. And as the pace of production accelerates, the story of these tanks becomes more than a tale of machines. It becomes a story of engineers, workers, soldiers, and the immense industrial effort required to transform a nation into a war machine. Detroit, late 1940. The hum of machinery fills enormous factory floors. Steam hisses from pipes. Sparks fly as welders join thick steel plates. Conveyor belts, once used to assemble automobiles, now carry tank hulls. The city, long known as the motor capital of the world, is transforming into something unprecedented, a factory-built armored army. What was once a civilian industry now operates on a scale dictated by war. Tank production demands materials, manpower, and coordination unlike anything the United States has attempted before. Engineers study German designs, analyze reports from France, and modify their own vehicles to withstand modern battlefield threats. Production targets are ambitious. At the Detroit Arsenal Tank Plant, leaders aim to build hundreds of tanks each month, a number that dwarfs any pre-war plans. Steel, engines, armor plating, and weapon systems flow from suppliers across the country. The industrial network hums like a vast organism, producing machines that are heavier, more complex, and more dangerous than the automobiles it once assembled. By spring 1941, the first American tanks begin rolling off the assembly lines, ready to be shipped to training centers and forward bases. The industrial miracle is real. A civilian workforce has adapted to create a modern armored force in record time. Designing tanks for modern warfare is not simple. The M2 medium tank, the first mass-produced American model, faces constant scrutiny. Armor must be thick enough to resist enemy fire, yet light enough to allow mobility. Guns must be powerful, reliable, and operable under combat conditions. Suspension, tracks, and engines are all under pressure to perform in mud, sand, and uneven terrain. Engineers work under extreme deadlines. Some spend nights testing new welding techniques. Others redesign turrets to fit larger weapons. Every design flaw could cost lives on the battlefield. They must anticipate what the German panzer divisions might throw at them. Collaboration with the Army is constant. Officers like Chaffee and Patton provide tactical guidance, explaining how tanks should move in combat, how crews should operate, and what vulnerabilities must be corrected. Every new prototype incorporates lessons learned from tests, reports, and even captured enemy vehicles. The result is a series of evolving designs. The early M2s serve as training vehicles, leading to the M3 Lee/Grant and eventually the M4 Sherman. Tanks that balance armor, firepower, and mass production in ways never seen before. The engineers' work bridges theory and battlefield reality, creating a machine that will define America's armored strength. Behind every tank lies a workforce of tens of thousands. Factory floors are filled with men and women learning new trades. Welders, machinists, assemblers, and riveters adapt to the unprecedented challenge of constructing armored vehicles in mass quantities. Many are young. Some are veterans of automobile factories. Others are newcomers to industrial labor. Women, long underrepresented in heavy industry, take on critical roles. They operate presses, assemble engines, and manage logistical chains. Each worker is part of a massive choreography where precision and timing are crucial. The work is exhausting and exacting. Steel plates weigh hundreds of pounds. Engines are temperamental. Tracks must be perfectly aligned. A single error could compromise the tank in battle. Yet there is a shared sense of purpose. The urgency of global war drives them forward. Each rivet, each turret, each engine installed represents not just a machine, but the potential to shape the course of the conflict. The story of the tanks is inseparable from the story of the people who build them. Detroit is no longer just a city. It is the crucible of America's armored power. And as tanks roll off the lines, the United States moves closer to confronting the battlefield challenges that Europe has already experienced. Tanks are only as effective as the men who operate them. As American production ramps up, the Army begins training crews at specialized centers across the country. Recruits learn to drive, maintain, and fight in vehicles that are heavier and more complex than anything most have experienced. Training is intense. Crews practice gunnery, maneuvering over rough terrain, and coordinating with infantry and artillery. Simulated battlefield exercises teach them to respond to ambushes, exploit breakthroughs, and communicate under fire. Officers emphasize speed, precision, and teamwork. the same principles that had made German panzer divisions so effective in Europe. Leaders like Patton instill an aggressive mindset. He believes that hesitation in armored warfare can be fatal. A tank must strike with confidence, he often says, pushing trainees to think like mobile spearheads rather than static supports. By 1942, the first American armored divisions are combat-ready, composed of soldiers who have learned to merge human skill with mechanized power. Across the Atlantic, German intelligence observes America's industrial mobilization with interest, but perhaps with some underestimation. Reports note the massive factories in Detroit, Chicago, and elsewhere, producing tanks, engines, and armored vehicles at unprecedented scale. Yet the Germans, battle-hardened from campaigns in France and the Low Countries, remain confident in their tactics. From the German point of view, American tanks are initially underpowered, lacking armor and firepower compared to the Panzer III and IV. Early models like the M2 are seen more as training vehicles than battlefield threats. However, analysts recognize a long-term risk. The sheer scale of U.S. production could overwhelm Axis forces if fully mobilized. This perspective highlights the dual nature of industrial warfare. Tanks alone are not decisive. The combination of production capacity, trained crews, and logistical support determines their impact. By late 1942, Germany begins to understand that America's arsenal of steel may become a decisive factor, even before a single tank reaches a frontline battle in Europe or North Africa. Producing tanks is only part of the challenge. Moving them from factories to training centers, ports, and eventually overseas requires an enormous logistical network. Railways, highways, and shipping lanes must be coordinated with military precision. Specialized transporters carry tanks from Detroit to the coasts, where they are loaded onto cargo ships bound for Europe and North Africa. Each shipment involves meticulous planning. Tanks are heavy and require reinforced decks on transport ships. Spare parts, ammunition, and fuel must accompany every vehicle. Maintenance crews are trained to service them in the field. Coordination with Allied forces ensures that once the tanks arrive, they can be deployed effectively. The logistical effort is unprecedented. For the first time, a nation mobilizes its industry not only to produce weapons, but to guarantee that those weapons can reach distant battlefields in combat-ready condition. The process transforms America into an industrial and military machine capable of global reach. By 1942, the combination of production, training, and logistics has created an American armored force ready to face real combat. The first true test lies across the Atlantic, in the deserts of North Africa, where steel and skill will be weighed against veteran German panzer divisions. November 8, 1942. The beaches of North Africa are cold, gray, and shrouded in morning fog. Ships carrying thousands of Allied soldiers approach the coast of Morocco and Algeria, part of an operation that will mark the first major American offensive in the European theater, Operation Torch. Onshore, American tanks rumble off landing craft into sand, mud, and scattered debris. For many of the crews, this is their first experience under fire. The M3 Lee tanks, though heavier and more powerful than earlier American models, are still being tested in the crucible of combat. Crews must navigate difficult terrain, unreliable maps, and sporadic coordination with infantry and artillery units. The enemy is waiting. Veteran troops of the German Afrika Korps, led by seasoned commanders, observe the American advance. They have faced mobile warfare before and understand how to exploit inexperienced armored units. Early encounters highlight weaknesses in the U.S. approach. Limited communication between units, slow adjustments under fire, and vulnerability to German anti-tank guns. Despite these challenges, the Americans push forward. Tanks engage in their first large-scale combat maneuvers, attempting to coordinate attacks with infantry and artillery support. Crews quickly learn that speed alone is insufficient. tactical awareness, combined arms cooperation, and quick decision-making are essential for survival. By the third day of combat, several lessons become clear. The M3's firepower is capable of neutralizing lightly armored German vehicles, but its high silhouette and limited turret traverse create vulnerabilities. Crews adapt, learning to use terrain for cover, coordinate flanking maneuvers, and rely on rapid communication to prevent isolation. Meanwhile, the scale of the industrial effort begins to show its importance. As tanks are damaged or destroyed, replacement vehicles arrive in numbers previously unimaginable in Europe. Where German panzer units often rely on repaired depots and captured equipment, the Americans can supply new machines almost continuously, thanks to production lines still operating in Detroit and other industrial centers. Leadership plays a decisive role. Officers trained under Patton and Chaffee's doctrines guide inexperienced crews with precision, correcting mistakes on the fly and instilling confidence. Tank commanders adapt to desert conditions, learning to read sand dunes, anticipate ambushes, and maintain mobility under fire. By the end of the first week, the Americans have established beachheads and secured key supply routes. The combat is far from perfect. Mechanical failures, inexperienced crews, and tactical errors persist, but the foundation of a capable armored force is visible. What began as a theoretical army of steel on paper has been tested against seasoned Axis forces and, despite setbacks, has survived. The desert proves a harsh teacher, but it also validates months of preparation. Factories, engineers, and crews are beginning to operate as a single coordinated system. American armored units, once non-existent, now represent a growing challenge to German forces in North Africa. This initial test will shape the remainder of the campaign. Lessons learned in these early battles lead to design improvements in tanks, refinements in training, and better coordination between infantry, artillery, and armor. Each encounter reinforces a simple truth. Industrial might alone is not enough. Skill, adaptation, and leadership determine success on the battlefield. As November fades into December, the United States Steel Army has faced its first real test. It has survived, it has learned, and it has proven that the factories of Detroit can transform raw materials into weapons capable of confronting the most experienced armies in the world. The battle in North Africa is only the beginning. Lessons from these engagements will drive rapid improvements in tank design, production, and battlefield tactics, setting the stage for the rise of the M4 Sherman and the full-scale armor campaigns that will follow across Europe. Early 1943. Across the deserts of North Africa, the American armored force is evolving under fire. Crews have learned to navigate sand, maintain vehicles under extreme conditions, and respond to German tactics. But the battlefield continues to expose both strengths and weaknesses. The M3 Lee, now in wider deployment, demonstrates reliable firepower against lightly armored German vehicles, but its design limitations remain. Its high profile and restricted turret traverse make it vulnerable to flanking attacks. Engines overheat under the relentless desert sun. Crews improvise solutions, draining sand from tracks, reinforcing cooling systems, and modifying firing positions. Each engagement becomes a lesson in adaptation, a real-world testing ground for machines that were once only drawings on an engineer's desk. Meanwhile, back in Detroit and across American factories, production does not pause. Learning from feedback from the front lines, engineers accelerate the development of the M4 Sherman, a tank designed to address the M3 shortcomings. Armor is improved, turrets redesigned, engines strengthened, and mass production techniques refined. The industrial machine hums with urgency. Delivering vehicles faster than the battlefield can destroy them. By mid-1943, the American Steel Army begins to demonstrate its true potential. Newly trained crews rotate into North Africa with upgraded vehicles. Combined arms tactics, linking armor, infantry, artillery, and air support become more sophisticated. Coordination improves as officers apply lessons learned from early engagements. The desert, once a testing ground, becomes a proving ground. The Germans take note. Reports from the front indicate that American tank units, though inexperienced at first, are increasing in effectiveness. The sheer number of vehicles arriving in theater begins to strain Axis logistics. While German panzer units remain tactically superior in skill, they cannot match the scale and relentless output of American industry. Factories in Detroit, Chicago, and other industrial centers are now producing thousands of tanks each month, and more on their way across the Atlantic. This interplay between industrial might and battlefield experience defines the turning point of America's armored capability. Machines evolve, crews evolve, tactics evolve, and every lesson feeds back into the production lines, creating a cycle of continuous improvement. By the end of the North African campaign, the United States has not only supplied itself with armored forces, but has also built a system capable of sustaining long-term combat. Factories, engineers, and soldiers are operating in unison, producing an armored force that is more than the sum of its parts. Victory in North Africa is not achieved solely through machines or manpower. It is achieved through the integration of industry, technology, training, and logistics, a formula that will define American armored warfare for the remainder of the Second World War. As the campaign concludes and attention shifts towards Sicily, Italy, and eventually the European heartland, one fact is undeniable. The United States, which entered the war with almost no modern tanks, has transformed into a global armored power. The first major test of American armor has concluded, but its impact resonates far beyond the deserts. Factories continue to churn, lessons continue to be learned, and the Steel Army begins to reshape the balance of power in the Allied war effort. By mid-1943, the impact of America's industrial mobilization becomes undeniable. Across Detroit, Chicago, and countless other cities, factories hum day and night, producing tanks at a pace that eclipses the expectations of military planners. Where the United States had entered the war with fewer than 400 tanks, it now fields tens of thousands of armored vehicles, each the product of relentless engineering, assembly line precision, and human labor. The numbers are staggering. By the end of 1943, American factories have produced more than 30,000 tanks, including M3 Lees and the increasingly dominant M4 Sherman. Every month, shipments cross the Atlantic, supplying Allied forces in North Africa, the Middle East, and eventually Europe. The industrial machine of the United States, dubbed the Arsenal of Democracy, demonstrates the true power of organized, mass production applied to warfare. Yet quantity alone does not define the achievement. The factories have produced tanks that are reliable, effective, and increasingly suited to combat conditions. Crews trained in the deserts of North Africa are ready to operate the vehicles in Europe and the Pacific. Engineers continue refining designs, integrating lessons from frontline combat into production lines, ensuring that each subsequent batch is more capable than the last. Allied nations take notice. Britain, engaged in prolonged conflict with Germany, welcomes American tanks into the Mediterranean theater. Soviet forces, facing immense pressure on the Eastern Front, receive shipments under Lend-Lease, including thousands of Shermans and support equipment. American industry has become a force multiplier, not just for its own armies, but for the entire Allied effort. The scale of production is unprecedented in military history. Factories capable of building automobiles and consumer goods are now churning out vehicles designed to withstand artillery, navigate hostile terrain, and deliver devastating firepower. Thousands of workers, many of them women entering heavy industry for the first time, sustain this momentum. Engineers, designers, and military planners continue to iterate, creating an unbroken cycle of innovation and output. By 1944, the transformation is complete. The United States, once unprepared for armored warfare, now possesses the largest and most versatile tank-producing system in the world. This industrial capability will prove decisive in the campaigns in Europe, where Sherman tanks and their crews will spearhead advances through France, Belgium, and Germany itself. The American Armored Army, born of necessity, built in factories, and hardened in battle, stands as a testament to the nation's ability to convert industry into weaponry on a global scale. The deserts of North Africa were only the proving ground. The real potential of this steel army will be fully realized on the battlefields of Europe. The consequences of America's armored mobilization extend beyond numbers. They redefine strategy, influence enemy planning, and reshape the very way wars are fought, signaling a shift toward industrialized warfare on a global scale. By 1944, the United States Steel Army is no longer just an industrial achievement. It has become a strategic instrument of war. The M4 Sherman, now mass-produced in tens of thousands, dominates American armored divisions. Its combination of reliability, moderate firepower, and ease of production allows the Allies to field more tanks than the Germans can effectively counter. In Europe, American armored divisions spearhead major operations. During the Normandy invasion in June 1944, Sherman tanks roll off landing beaches, linking with infantry and artillery to break through fortified positions. Across France, they exploit gaps in German lines, enabling rapid advances that were unimaginable just 4 years earlier. The desert lessons from North Africa, coordinated movement, combined arms tactics, and logistical discipline, now prove decisive in temperate European terrain. Industrial might continues to shape strategy. Where German panzer divisions are limited by attrition and supply, the Americans can replace lost vehicles almost immediately. Factories in Detroit, Chicago, and elsewhere maintain a steady flow of new tanks, spare parts, and support equipment. The logistical network ensures that armored units remain combat-ready, reinforcing the principle that sustained production can be as decisive as battlefield skill. Beyond Europe, American tanks influence global conflict. In the Pacific, armored units adapt to jungle and island warfare, providing fire support, engineering capability, and mobility. Even in theaters where terrain limits traditional tank maneuvers, the very existence of a mechanized force alters enemy calculations. Axis commanders must account for American industrial capacity, knowing that any localized victory can be countered by new equipment arriving from across the ocean. The broader lesson is clear. Industrial power and battlefield effectiveness are inseparable. The United States entered the war with almost no modern tanks. Within 3 years, it not only produced a formidable armored force, but also created a system capable of sustaining it under prolonged combat. This combination of engineering, production, training, and logistics becomes a model for modern mechanized warfare, influencing military doctrine long after the Second World War ends. By the time Germany surrenders in May 1945, American factories have produced over 88,000 tanks, more than the combined output of most Axis nations. The strategic impact of these machines extends beyond statistics. They embody the nation's capacity to convert industry into decisive battlefield power. The story of the American Armored Army is therefore not merely one of combat success. It is a testament to foresight, organization, and the ability to transform a civilian economy into the backbone of global warfare. The story of America's armored forces is, at its core, a story of transformation. In 1940, the United States entered a global conflict almost unprepared for mechanized warfare. Its tanks were few, its doctrines untested, and its industrial system geared toward peace. Within a few short years, however, the nation demonstrated an extraordinary capacity to adapt innovate and mobilize. Detroit's factories became more than production centers. They became instruments of war. Engineers, designers, and assembly line workers learned new trades and overcame unprecedented challenges. Crews trained in the deserts of North Africa converted mechanical potential into battlefield effectiveness. Tanks that had existed only as drawings on paper became decisive tools of strategy, capable of shaping campaigns across continents. Yet the true significance lies not in the steel itself, but in the integration of people, technology, and industry. The United States showed that modern warfare is not won by individual heroism alone, nor by superior tactics in isolation. Victory depends on the capacity to align production, logistics, training, and strategy into a seamless system. The armored divisions of the U.S. Army were more than machines. They were the culmination of a nation's ingenuity and determination. In a broader sense, this transformation redefined what it meant to wage war. Mechanized armies, once a curiosity, became central to strategy. Industrial power became as decisive as battlefield courage. And the example set by the United States demonstrated that even a nation starting from a position of relative weakness could achieve overwhelming strength when industry and human skill are fully harnessed. The steel that rolled off the assembly lines did more than crush enemy armor. It reshaped the very nature of conflict. Factories, workers, engineers, and soldiers together forged a new form of power, an army of steel capable of meeting the challenges of a mechanized world. In the end, the story of American tanks is not merely a story of machines. It is a story of a nation discovering how to turn its potential into decisive action, forever altering the course of history.